So this is GATE 2014 question number 40, which states that for a system of two bosons, each of which can occupy any of the two energy levels, 0 and epsilon. So the energy levels are given. Particles information is also given, that these are the bosons. What we need to find out is the mean energy of the system at a temperature T with beta is equal to 1 upon kBT is given by, there are several options which are given. So we need to find the mean energy of the system. Okay, let's see what is the solution for this particular problem. So it is given in the question that for a system of two bosons, which can occupy any of the two energy levels, 0 and epsilon. So we need to know that for bosons, there are certain characteristics. They are, first of all, indistinguishable particles. Indistinguishable particles. No two particles are same, all are same. So you cannot distinguish between them. So these are indistinguishable particles. And number two is that any number of bosons can occupy a particular energy state. So these are the two key points which we need to remember. Energy state. Okay. Now what we need to find is the mean energy of the system at temperature T, where beta is given as 1 upon kBT. So based on these two things, we can find out how these two bosons are distributed at different energy levels. So there are two energy levels given in the question, 0 and epsilon. 0 is the ground state, epsilon is some excited state. Now two bosons are there in the system. So as we know that any number of bosons can occupy a particular energy states. So the two bosons can occupy the 0th energy state, or the two bosons can occupy the epsilon energy state, or one boson can occupy 0 and one boson can occupy the epsilon energy state. So there are three possible ways to do so. Now we define a term, the partition function. So in order to understand that what is the mean energy of the system, we have to go in this particular way. So we need to find out what is the partition function of the system. So what is this partition function? How it is defined? So what this partition function tells us is that partition function means, it indicates that how the gas molecules of system are distributed, or in other words the partitioned, which goes to this partition function, partitioned among various energy levels. So this is what the meaning of this partition function Z, and Z is defined as summation for different ith energy levels. So e to the power minus epsilon I upon kBT, where kBT, 1 upon kBT is defined here in the question as beta. So I have written it as summation I e to the power minus epsilon I beta, where epsilon I is the ith energy level. Fine. Actually the partition function is defined like this. It is I with some degeneracy gi e to the power minus epsilon I upon kBT. Now what is this di? Is the degeneracy number. Degeneracy. So what is this degeneracy means? It means that the number of energy levels with same energy. In this case it is 1, because the number of energy for 0 it is only 0 energy, for epsilon it is only epsilon amount of energy which is there. So degeneracy in this case will be equal to 1. Okay, so that's why I have written it e to the power minus epsilon I by kBT, because degeneracy means the number of energy levels with same energy. So in this case it is only 1. So Z becomes, therefore, if we just see that for each of the cases what we have seen here. So for the first case we have seen that the two particles are there in the 0th energy state. So Z is e to the power minus 0 into 2 beta, because two particles are there and 0 energy state. Second one is e to the power minus epsilon into 2 beta, because two particles are there in the epsilon energy state. And the third one is e to the power one particle or one boson is at the 0th energy level, another is at the epsilon energy level. Therefore, we can write it like this. So actually it is written like this, e to the power minus beta into 0 plus epsilon, the total energy which are there. Okay, so this is how it is written. Finally, we get 1 plus e to the power minus 2 beta epsilon plus e to the power minus beta epsilon. This is what we are getting as the partition function. That is how the gas molecules of the system are distributed among various energy levels. Now, the mean energy of the system is defined using partition function using this particular way. Minus delta delta beta, where beta is 1 upon kBt log of z. So minus delta delta beta log of this particular term, the partition function which we have seen. Once we do this derivative, so it will be derivative 1 upon log, so log will be 1 upon this particular term, the z, it will be there, and finally this has to be differentiated with respect to beta. And once we do this, we get this kind of a solution where we get epsilon e to the power minus beta epsilon plus 2 epsilon e to the power minus 2 beta epsilon divided by the partition function which we have got. And that is nothing but the mean energy of the system. And as we can see that I have written here, none of the answers are correct. In this particular question, we can see that these three options B, C, D are not correct at all. A is to some extent correct, but there is a 2 which is present here, which is not there in our case. So that's why none of the options are correct in this particular question. So we have seen that how to know that what is the mean energy of the system, whether there are two bosons or fermions. This is the how we should proceed. First we find out the partition function of the system Z, and then in order to understand what is the total energy or the mean energy of the system, we have to differentiate with respect to beta, where beta is this 1 upon kBt log Z. If you do this, this will give the total average energy of the system. Thank you.